There we go. Thank you very much. So, very warm welcome to everybody for joining us on what is our last webinar of 2021. A little bit sad, but delighted because we've got such great content for you today, plus a very special guest. So, this webinar series, we are going to be focusing on how to design Wi-Fi in higher education. And you have got obviously myself, my lovely co-host Mac. We have got the legend Mr. Stu Gomans manning the Q&A, and a very special guest. You know, I suppose you can just never have too many Matts. So we've got another Matt Seymour, doing his victory lap off the back of the Wi-Fi Design Day event in the UK. We loved it so much, we thought we need to get him on here so we can dive a little bit deeper into his higher education presentation, because it was fantastic. So very welcome, Matthew Seymour.
Well, thank you very much. I feel very well sold there. That's that's great. And thanks, guys, for having me on. And yeah, it's been a lot of fun being involved in Wi-Fi Day, and it's been great to be able to kind of look at expanding some of the stuff a bit more. So, shall we jump straight into it?
Yes.
And so. Yeah, I want to kick off with the same thing I said at Wi-Fi Day. So hi to anybody who was at the British Museum. What a fantastic event. I think universities are possibly the best place to learn Wi-Fi, and that kind of needs to be qualified, doesn't it? Need to kind of show you working a bit. And it comes down to the variety. There's so many different kinds of buildings, there's so many clients, there's so many different requirements, and there's just loads of stuff going on. The problem is a bit too much going on, and it can be quite hard to kind of get it all in a box and get it manageable and kind of know what you're doing. And some universities cope with that really well, and some don't cope quite so well. But I think we joke about the importance of Wi-Fi, don't we? And we talk about Maslow's hierarchy of needs and where Wi-Fi sits on that. But on a university campus, connectivity is massively important. And that may seem really obvious, but it's worth saying. And Wi-Fi is king of the connectivity. We all know that, right? Wi-Fi is best. Everything is connecting via Wi-Fi, and students don't plug stuff in anymore. Even if they still have a network socket on their laptop, they ain't using it. They're on the Wi-Fi. But yeah, we joke about this stuff a little bit, and I'm going to tell you a little story about being in a university building. There's a halls of residence, so it's like a 3 or 4 story building people are living in, and there was a really serious plumbing failure, which for some reason all the plumbing was on the top floor. It's where we like to keep large quantities of water for some reason, and it was all kind of pouring down the interior walls of the building, and this was a bad time for the people who were living there. And there it was, coming kind of down the AP, sort of dripping nicely. That was still working till we realized there was also water pouring down the kind of 400-volt mains electrical incoming panel for the building, and we didn't think this was a very good idea. So somebody went to turn that
Totally
off.
shocking.
And yeah, well, this is, you don't want to lick it. And we're all kind of squelching around because there's a lot of water, and it's kind of coming out into the carpet, into the corridor, and it's everywhere. And we're like, yeah, we should turn that off. And someone else went and try and find the water, turn that off. And then at that point, once we turned off the power, this guy comes out of his room and he's walking down, he's sort of squelching barefoot down the corridor, and doesn't bat an eyelid about that, but he's got his phone in hand and he's like, is the Wi-Fi down? Yeah, the Wi-Fi's down, as is the water supply, but he didn't care about that. So this was all happening at the University of York, which is a place, it's where I live. I live just outside York, and I worked there for about 5 years. So I learned an awful lot. This is why I say it's a great grounding in Wi-Fi and connectivity. And it's a really lovely campus. It was a kind of modern university built in the 1960s, just outside the city of York in the UK. And because it was built in the 1960s, as you might imagine, there's a lot of concrete. This kind of, we've got this spaceship thing here, this thing called Central Hall, and then you can see to the left behind that is a really interesting building. I'm going to talk a bit more about not that particular building, but that type of building, something called clasp. So yeah, there's all this kind of slightly brutalist architecture. That brings its challenges for us. You know, getting through reinforced concrete can be a challenge, but this particular university also has this place. This is called Heslington Hall. This is where the university first started, and it's originally Tudor, originally kind of 15th century, I believe, but most of this is 19th century, and no one's really that bothered about it. It looks very fancy though, doesn't it?
Matt, I think you're forgetting to mention probably one of the biggest things and most important things to come out of York is great tea, and especially for the US on the show today.
Oh man, Yorkshire tea. Yeah, somebody offered me some tea that wasn't Yorkshire tea recently, and I just walked straight out of there.
Can't blame you.
Got no time for that. Yeah. Also, the band Shed 7. Kind of got to mention them. No. Okay, never mind.
No, I don't know. I don't know who those people are.
Oh dear. Yeah. It's so you know. Now this, you think this building looks fancy and old. There's something coming up. So we've got that one. We've got this. So this is another kind of fairly typical thing you'll get at a university, I suppose. This is the law school at the University of York, and it's a brand new building. Nothing's straight. Kind of inside looks like that. And this is quite fun from a Wi-Fi deployment perspective, because the architects don't like you mounting anything anywhere. So you've kind of got to hide it and think about the aesthetics. So that's, you know, that has its challenges. This one's fun. So this is right in the centre of York. If anyone's ever been to York, it's kind of a mostly medieval city, but then you've got kind of the Roman walls, and you've got Vikings and all sorts of stuff going on. And this building was a abbot's residence. It dates from about the 11th century, some of it. And then when Henry VIII abolished all the monasteries, he made this his seat of the Council of the North. So there's a bit of history in this place, I think it's fair to say. And I don't know why there's a sort of bull sat there on the plinth. Anyway, but if you want to start drilling holes in this, people get really upset with you. So yeah, it'd be interesting to know if anybody has ever worked on a building older than this. I'm kind of thinking
it does look a little bit like it could be haunted. Yeah, Sandra, I agree. Yeah, not sure I'd feel too brave performing my Wi-Fi surveys in there
at night when everyone's gone home.
Yeah.
And here's a deeply uninspiring building put up in the kind of mid-90s, I think. So there we go. You know, we've got a shed load of all these different buildings, and I think that's one of the things that makes universities really unique and really special, because you tend not to get that in any other kind of organization. You kind of, you know, your business park, it doesn't have an 11th century abbot's residence for the most part. So that's kind of where I come from in there. So let's move on to requirements a little bit and think about, if we're going to do a Wi-Fi design, this is kind of where we start, isn't it? We need to know which devices need to do what and where. That's the basics of our requirements. Now, I don't think you will get that information when you are working at a higher education institution. Certainly, that's my experience. It's experience of lots of people I've spoken to around the UK, and it'd be really interesting to know for everybody. We've got a worldwide global audience here. Is this the experience everywhere else too? I suspect it probably is, for all the reasons I want to go into in a minute. But yeah, let us know in the chat. If you work in a university, say in the US, do you have difficulty getting requirements out of people? So we've got a poll.
Ooh, we have our first poll question of the day.
Exciting. Okay, so let your favorite poll read the poll. So question number 1 is, what minimum signal strength do you typically design for when clients are laptops and cell phones? A, next 60 dB, B, next 62 dB, C, next 67 dB, and D, neg 70.
Okay, we will let everyone finish answering, and I will now end the poll, and I will make sure I share the results so we can all see. So there we go. So it looks like, I mean, the biggest bunch of people want to go for neg 67 dBm.
And that's kind of no surprise, isn't it? Because that's kind of the Cisco best practice that's been talked about for kind of Cisco VoIP phones from the year dot, and it's the default in Ekahau.
Look at the chat, guys. We have tons of neg 65s as well.
And you see,
very VHD.
Yeah, I should have put that in, shouldn't I? Should have put that in. Anyway, I wasn't, I kind of threw this in because I wasn't thinking, is there a right answer? Is there a wrong answer? I was just interested to see what people said. Okay, so let's move on. Come on, there we go. Right, so here is the first reason why I think you have great difficulty getting your requirements. And this is the biggie. It's the fact that it's the ultimate BYOD environment. When you are at a university campus, you just, I mean, some of these aren't really Wi-Fi. I just like this photo. But you don't know what the clients are going to be. Students will turn up with literally anything at all. Now, I mean, Matt, you've done loads of work in warehouses and you've done loads of work in offices, and in those scenarios you know what the client's going to be, that you know what you're designing for.
Yeah, typically you, especially in those kind of environments, you can really gather that information and find out, you know, what is the make and model of the barcode scanners in the warehouses. And we were actually quite lucky in one of our warehouse projects where we got to, you know, help the customer purchase the client devices for the warehouse. We could make sure, you know, they were buying, you know, client devices that were going to work really well with the Wi-Fi. Not every time you're quite so lucky, I would say. Even in offices, sometimes you can't guarantee, you know, what are, other than the corporate devices connecting to the corporate network, like the laptops and maybe the corporate issued mobile phones, all other devices, you're kind of just hoping that they are not going to be too old. They're going to support all the bells and whistles that you want to have switched on, but it's not necessarily guaranteed. And I just want to say to people that's joined today, if you have any questions for Matt, by the way, please feel free to use our Q&A and throw some questions in there. Matt loves taking unplanned questions, so we can put him right on the spot. So feel free to chuck any questions that you'd like us to throw at Matt in the Q&A, and then Stu can go and grab the really tricky, difficult ones that you want us to make sure we get answered for you.
So, I mean, that's got to be living the dream, though, that when you get to say to the client, we think you should buy this, and then you get to design a network for that thing, and mate, that's great. So yeah, it's not my experience. Students turn up with all kinds of stuff, and I mean, I've seen some really interesting devices. I've seen a lot of Apple devices. Not very long ago, I saw a brand new laptop that a student had just had bought for them by their parents, and it was 2.4 gig only. That wasn't great. I think I'm right in saying we're just about at the point now where you can't buy a brand new 2.4 gig only laptop. I did have a little bit of a look around a few of the retailers on the high street, and they're not selling them anymore, so that's good stuff. But you know, these things can turn up. I think probably the best thing I saw, by best I mean worst, was a student from overseas student from Malaysia, and she'd got this phone, and this poor girl came up to me and was like, "What is happening with my phone?" I'm like, "I don't know. Let's have a look at it." And she got connected to the Wi-Fi network, no problem at all. And the phone was bombarding her with adverts, and some of them were really kind of quite dodgy. And it was just had all this adware built into the phone. It was extraordinary. And it was previously, she was working on a network that kind of blocked all this stuff. Come to our network, you can get to everything. And yeah, it wasn't good. So you just don't know what the devices are going to be, what condition they're in, how many times they've been dropped. you know, what kind of malware they're running. It is a proper Wild West. And so, yeah, client devices, that bit is completely out of the window. And we have this idea when we're talking about wireless design, and often when we're trained in it initially, we have this idea of this least capable, most important device. And what's the example for that?
That's typically how I describe Mac to people.
Yeah. I hear is important.
Yeah,
certainly. I feel like I can't say anything now because I don't want to abuse Mac. He's a great guy. What's a good example of the least capable, most important device? We kind of talk about. Again, it depends where you are, doesn't it? Right. So if you're in a warehouse scenario, it's that barcode scanner. That's the most important thing, isn't it? But we often in an office environment, we might think about the example that was always used was the BlackBerry. Long after BlackBerries had died, and people kept hold of them because they loved that physical keyboard. And so you had some kind of executive who was an important person and their opinion mattered, and they wanted to keep their old BlackBerry running. So that became our least capable, most important device. But in higher ed, I don't know what it is. I came up with some examples here because there's loads of cheap Chromebooks around on the market, and they seem to be quite popular because they're very affordable. We get Raspberry Pis by the bucket load, loads of those things around, and that's quite a quantifiable thing. But the Wi-Fi quality of the Pi does vary hugely. So you can get a good one that works quite well, and you can get another one that actually just seems to be quite poor. The cheap smartphone, like the poor Malaysian girl's awful phone that she got stuck with, and then you get the 2.4 gigahertz only laptop. You know, what do we choose? Where do we start? And I've never been able to really pick a particular device and say this is the one. So we ended up with that. And this is why we kind of asked the poll question, just because I was interested to see what people came up with. We targeted neg 60 in the Ekahau designs. And
I feel like this is a little bit controversial here, Matthew. Everyone's getting on their soapbox now.
I need to have a look.
I feel they might, it's not one of the typical values that people might be designing for. So
it's not, no.
To see what everyone thinks on the webinar today.
Yeah, and if you think this is a bad idea, or you want me to justify it a bit more, then by all means, just shout and say. I mean, I'll say how we arrived at that, and it's basically about saying that those of us who are really familiar with using the Ekahau Sidekick for our kind of validation work, you know that actually the Sidekick's got a really good radio. Okay, so you can walk around a building and it will give you a picture of how it sees the Wi-Fi. And so then you go, well, okay, but that's fine. My clients aren't using Sidekicks; they're using this barcode scanner or this smartphone or whatever. And so you can do a bit of work and you can find out, well, what's the offset, and we use then that in Ekahau to say we think this client, which is the one that matters to us, sees the network probably about 10 dB lower than the Sidekick does. And so we can then apply that offset to our visualizations of our validation.
I didn't remember seeing sales in your title, Matt. It's just because you want to sell some more access points.
Well, I mean, this is maybe the accusation, isn't it? That you set a kind of really kind of low threshold and then say, oh yeah, okay, so it's an access point per room then. And actually, I've seen people do that, but we'll kind of come on to that a little bit. It's a really good point. But we kind of ended up with this as our kind of target. And it's worth saying that this is a kind of granular thing. So there are some buildings when you're working on a design and you're not going to have neg 60 as your target in Ekahau because it's a great big open space, and so your approach is different. where we use NIG 60, where I always use NIG 60, is when I'm looking at a accommodation building primarily. So it's somewhere where you've got a lot of students and they have very high expectations of the network, and you have a very high number of devices that are maybe not actually very good in terms of the kind of Wi-Fi quality. Most importantly, we found this worked. So if you design for NEG 60, then you end up with happy users. That's the experience that we had.
Let's stop here for 30 seconds. We have a very good question about the NEG 60 and the offsets or a mobile view in Ekahau. Do we have any views about that? Is it better to design for NEG 60, or is it better to design with a mobile view toggled?
Oh, that's a really interesting question, isn't it? I started doing this before the mobile view was an option. And you know, when you've got a workflow, you tend to stick to it. So I think there's an element of kind of sort of what works for you. And this is something that I arrived at through doing designs in Ekahau, deploying it, and then validating it, and then testing with clients and saying, does this work? Is this delivering what the users are expecting? And initially, when everything was set to NEG 67, that's what we started out designing to NEG 67, because that's the kind of default that a lot of the industry uses. And what we were finding was that that was fine for a lot of clients. And it was as soon as you come across, I don't know, that particular smartphone or this laptop that's maybe just not so good, or the cheaper hardware, we were finding that then they just didn't quite get a good enough experience. But yeah, I think that's a really interesting question about the mobile view. It's something that I think you can use to give you a very similar response, and it's then a nice easy click to go, okay, turn that off. What are other devices going to see? What are my worst devices going to see? And that could be an approach and a workflow that works really well.
And that actually is a good follow-up there, Matthew, because you talk about that NEG 60 target. I mean, what would you look for a secondary? I mean, because that's going to be a much higher number now. I mean, it's a very aggressive number, which is actually awesome, to get some great signal. But what's your thoughts on that?
It's a really interesting one, isn't it? So when we look for kind of our secondary, what are we talking about? It's usually about roaming, right? And wanting to know how that client is going to roam around. And if you think about a accommodation building, I don't care about roaming, not really. We'll come on to this because we've got some, we're going to open up Ekahau and actually just have a look at a couple of buildings. But if you've got students who are in their room, they're not moving around the building. They're sitting in one place. These rooms are not really very large for the most part. They don't get a suite, they get a room. And what they want and what we need to deliver as the people designing that network is a really good Wi-Fi experience for all of those devices in that space. If they leave their room, they walk down the corridor a bit and the roaming isn't great and they lose connectivity briefly, I'm not sure that matters. This is all part of your setting your requirements, and it could be that in some circumstances your requirements say we need to be able to roam, in which case that secondary then starts to matter. As you'll see with the way that we end up kind of deploying APs in these buildings, actually the secondary is going to be reasonable, and actually the roaming is probably going to be okay. It's going to work quite nicely, but it's not part of the requirements list quite often.
And that's a great segue into kind of user requirements, right? And it's
look at that. Yeah, it absolutely is, because here we are. It's almost like we planned this, which genuinely we haven't. But requirements, oh man, these are my favorite thing, because again, in a higher ed environment, you have a lot of different requirements and you have a lot of different expectations, and it's really hard to know what they are going to be. there's an argument to say every user will come with their own bag of requirements. They might have a specific device they want to be able to use. It gets really, really interesting when you're talking about academics and research and anything that uses the network. That gets fascinating. There's some really interesting stuff. But I think that the key thing to understand is that a user will have different requirements depending upon their context and where they are and what it is that they're actually doing. So if we look at kind of some examples here, so we've got students, and so 3 different places that students might be. And I mean, they can go other places as well. I'm not, not pinning them down. But in each of these areas, study bedrooms, shared study space, and by that I mean somewhere like the university library, often a large, often open plan kind of space that can have a lot of people in it. And then you have lecture theatres, and these are completely different. And what students will be doing in them will be different, and therefore their network requirements different. Even for the same device. Then we have administrative staff, and a university like the University of York has about, I think there's about 3,000 staff, something like that. It's not a really huge number, considering how many students there will be. But yeah, these people tend to be sat at a desk. So they may even still be using like a desktop PC plugged in, but increasingly the move is to use laptops for kind of everything. And you might plug them into a dock, and that dock might be plugged into a wired network, but often it isn't because they've forgotten. So they can be on the Wi-Fi even if they don't realize it. And they're not doing very much with it. To be honest, most of the time, it's if you're sitting down working on a document, you're not hammering the network. Your internet requirements are low, and even then, you can unplug it, take it to a cafe, sit and do some collaborative work, sit in a meeting. Again, you're not really moving very much data. Researchers are where I think it gets really interesting. So by this, I'm talking about people who are doing some research that uses the network, and there's all kinds of stuff goes on. I think one of my favorite things that I did some work with was on a group who were doing research into autonomous robots. And so they needed these robots to be able to talk to each other and talk to other stuff in the environment around them and do things like control doors and interact with proximity information from sensors in the building. And if the fire alarm goes off, how do the robots know that the fire alarm's gone off, and how do they change their behavior to not get in the way? And all this kind of really interesting research this guy was doing, and he wanted them on the network. And so we were like, okay, that's a security question, isn't it? Because suddenly we want the Wi-Fi network to be able to talk to the building management, and we'd always kept those things really separate, and now suddenly we can't. So yeah, that's an interesting challenge that came up, and a unique set of requirements as well. I end up sort of creating these categories because when I look at all of this, the thing that always struck me was how big it all is, and how there's too many variables. You need to contain it. You need to kind of squash it all down into a box that you can manage. And actually that isn't that difficult. So here's what I think we've got. Administrative is our baseline. This is the person who's doing some Google Docs, they're maybe doing a bit of web browsing, they're not watching Netflix, then they're not doing lots of streaming. It's all kind of really low level. It's kind of a bit of email, a bit of documents. That's like our baseline for user traffic. Domestic is where we've got our student in their room. This is their home from home. They're living there for like, a good third to half of the year, and they are streaming, they're gaming, it's high bandwidth. That's where the bulk of the bandwidth consumed on campus ends up. It's being used by the students in their rooms. Research, as I mentioned, could be what the hell is that? Anything goes. It really can be all sorts of stuff. And then we have high density. And that I kind of split high density into two, because you've got kind of numbers, but you also have throughput, and they're not necessarily the same in the same place. So a good example of a numbers space would be somewhere like the library. So the university library can have a lot of students in it, and it can have a lot of students coming in all at once, and they stay all day, especially around Easter, because they're coming up to exams and they're really studying hard. And I've seen issues where a network that's not designed to handle the numbers falls over just around Easter, because everyone comes into the same space and it just can't cope with the client count. So you need to be able to handle that.
We've had a really good question come in regarding your 4 categories, and the question is, are you using separate VLANs, SSIDs with quads, or are you segregating these in a different way?
That is a really good question. So I'm looking at this from a perspective of RF requirement, rather than kind of the rest of the network. But there are all sorts of different ways you can do this. So the network that I kind of basing a lot of my thoughts around, I mean, I'm an Aruba guy, I work for HPE, so this was an Aruba network and everything was role based. So we tended to have VLAN pools. So we had, I can't remember how many VLANs we had, each with I think a /23 subnet. And they were pooled in such a way that users would always get thrown into the same VLAN no matter where they connected on campus. But actually, we didn't segregate their traffic by VLAN. We did that by the role that they were placed in once they authenticated, and the ACLs applied to them that way. Hopefully that answers the question. There's another side to high density, which is I need to mention, and that's throughput. So you can have somewhere like the library where you've got a lot of users, but they're not doing very much, and it's very predictable what they're going to be doing. You might have a bit of Spotify, a bit of kind of listening to Apple Music, because people need some tunes to study, and that's fine. But that's buffered. It's not really hitting the network very hard. But you can also have scenarios, and this is where the lecture theatre comes in, where you have 500 to 800 students in one space, and they all need to do something at the same time. One example we had of that was bringing in screen sharing, and the idea of having these boxes which multiple people in the room could all simultaneously share their screen to the big projector on the main back wall, and then the lecturer could say, oh yeah, you so-and-so will have you up, and they could bring their screen on. So you've got, I think, maybe 50 plus students simultaneously sharing their desktop, and so the bandwidth requirements with that were quite, they weren't huge, but they were enough that we really had to think about it. And that also appeared with oh yeah, this is something we're thinking of doing this term. There was no kind of warning of we're going to do this in a few months' time. Even it's like, oh, can we do this tomorrow? Yeah, so there was a bit of need to jump on that. But so that's kind of how I break down how I think about what we're going to need to deploy in an area, in terms of user count and bandwidth requirements. So that's what I found helpful. Here's an example of a library. I'm sure we've all seen libraries. We kind of have some sort of idea what they look like. So this is a sort of fairly typical. You've got kind of desk areas around the edges, and in the middle, sort of big block of shelves. And there was never any. Oh, can anyone see the AP just hiding in there? Old Aruba. There was never any need to try and cover kind of along in the aisles in between these shelves. We just didn't need to do it. Nobody wanted that. And I'm glad, because that would have been hard. They're metal shelves, and they've got like 3 feet of books on them. So actually, that's a fairly substantial kind of wall to try and push signal through. But what could happen, and it would happen really quickly, we'd have no warning. They'd decide that, okay, we don't need some of these books at the moment. What we need at the moment is more study space. And so you could come into a building that you'd nicely designed and you'd validated it and everything was fine, you're really happy, and all these shelves have gone, and instead you've got some desks. And so suddenly your user count requirements in that space have shot up, and no one has bothered to tell you that that was going to happen. And this is the sort of fairly typical thing I would find, is that actually things could move quite quickly. You can expect that there'll be meetings and discussions, and everyone will be brought in, and we'll talk about it. This is academia after all. And actually, no, it's all very quick. It's like, we'll just crack on, shift those out of the way, and then, you know, we as the IT services would have to respond really quickly in order to kind of meet expectations. So that could be fun. And a really good example actually of when we got that wrong, because I think that's a great place to learn when something doesn't work and you have to go, well, why do we have a problem here? So we had a room. It wasn't actually this one, where there was a single AP providing great coverage for the clients in that space, and there'd been no problem. It had been that had been the case for a long time, and it had recently been validated because the whole library was kind of redesigned, and you know, we'd added a lot more APs, moved them all around, and you know, upgraded them. So we'd done the full validation, and that room was absolutely fine, no problems at all. And then we suddenly started getting calls to say people can't connect. And I was like, oh, well, I know it's fine. Actually, it must be their device, because I know my network's got no problems at all. So I kind of quite smugly went up with my laptop just to go and prove that everything was fine. And of course it wasn't. I went into the room and I could see a good signal strength, and then I associated with the Wi-Fi with a terrible signal. I'm like, oh, okay, so we do have a problem. And it was a really simple one. We had simply hit the client limit of that AP. We had too many people, and they'd taken some of the shelves out, not many, just, you know, brought in a few more desks, made it a bit more flexible as a space, a better study space, and suddenly we were just tipping over the client limit for our AP. And you know, there is a useful lesson in that, which was we should have spotted that in our monitoring, and so we fixed that and sorted out in Airwave how to make sure it was going to warn us that we were getting near client limits. But yeah, it can happen. Sort of, it sneaks up on you. You don't necessarily know it's going to happen, and suddenly you find, yeah, we are no longer meeting the requirements for this space, and that was easily dealt with by, you know, just installing a few more APs, which provided a better service anyway. But you know, it's these little learning opportunities which are quite good. I was going to talk to you about clasp buildings, wasn't I? Let's look at one. Let's look at one in Ekkerhouse, shall we? Let's have a look. Where's Ekkerhouse? It's here. Right. I'm sure we're all familiar with something like this. So here we have a building. It's not very interesting. It's a sort of oblong. It's multi-stories, but we aren't going to concern ourselves about that. We're just going to look at this one story. And so we've got this corridor up the middle, and we've got rooms off it and some walls. So it's kind of pretty basic. Now, if I were to tell you this is a steel frame building, it's got poured concrete floors and some concrete panel outer walls, you'd probably say, yeah, I've seen plenty of those. That's pretty common. And therefore, all of these interior walls are going to probably be drywall, plasterboard. There'll be probably about 3 to 5 dB attenuation. And yeah, I'd agree with you. I think that's probably the case. Now, I need to tell you a little bit about this building before we go any further. It's a clasp building, and That stands for the Consortium of Local Authorities Special Projects or Special Programs, or something like that. And a tiny little potted history of it is it was begun in 1957, and the idea was it was how in the UK we were going to deal with the need for more buildings. So we needed hospitals and universities and schools, and in some areas of the country there was a lot of recovery still happening from World War II. So we needed to do this quickly and efficiently, and just come on, get on with it. And this was one of their ways of doing it, and it was almost like a building system that was cheap, fast, easy to design for, and you didn't need to be an architect to design your building, so you could just kind of do it with a kit of parts. And now we're kind of 50, 60 years on, we're dealing with the problems of these buildings, which are that they were cheap, and a cheap building often isn't great. So they're thermally disastrous, so they're very hot in summer, very cold in winter, and the biggest problem is they're full of asbestos. So that's great, isn't it? Anyone who's ever done any asbestos awareness courses, will know how challenging asbestos can be. And those of us that work in the network industry, along with kind of builders and electricians and plumbers, anybody who's working in these old buildings, pulling cables and poking around, we're kind of at risk, and we've got to be careful about some of this stuff. So one of the challenges that you have with a building with asbestos, especially if you've got asbestos in the ceiling void, which this does, means you can't go into the ceiling. And you can't really drill holes in the walls because it's asbestos, and you can't even drill through like the door reveals, the edge of the door frames, because they're either metal or asbestos. So you end up taking the easy route. And this is the easy route. We've got APs in the corridor, which we know isn't cool, but it looks all right, it works. We kind of think this is fine. We should note that this simulated AP, Rubra AP315, is an AP designed to go on the ceiling, but we can't mount it on the ceiling because asbestos. So what we've done is we've just stuck it on the wall, because it'll be all right, won't it? That's why what we've done, just if we look into the AP, we can see that the default is it's ceiling mounted. This one is wall mounted, and that gives you a direction. Hence why we've got what looks like directional antenna on these APs. It's not really, it's the fact that we've mounted them incorrectly as far as the manufacturer is concerned. So anyway, we think this is probably okay, right? Probably. So even if we wind this up to sort of there, it's still sort of all right, isn't it? But there is another problem, which is that some of these walls are not drywall. They're a material called stelvatite, which I wouldn't be surprised if people haven't heard of. I hadn't heard of it. But basically what it is rolled steel covered in plastic. So it's just sheets of metal. And it was used a lot in building in the late 50s and early 60s. I don't really know why. It's quite cool for an office wall because you can just get kind of fridge magnets and board magnets and stick stuff to the wall, which is, it's quite a nice thing to be able to do. But unfortunately, it doesn't help us with our Wi-Fi. So what we've got here is a 3dB wall, but it's not a 3dB wall. Actually, let's make sure we select the right wall. It's not 3dB, it's hidden. It's actually about 25 dB. There we go. Ooh. So there we go. There's closer to the reality of what we've actually got in the space.
Ouch, indeed. Ouch,
well, that's kicking it up a notch, isn't it?
It's not so good, is it? So what we can do is just let's just put this back to 67 and say that'll do. Oh, it's still not great, and this office isn't happy, and yeah. So what would you do? I tell you what I'd do. What I would do is I'd go, okay, fine. So these corridor mounted APs, these don't work. So what I need to do is I need to get my new AP, and I'm putting new ones in. So they're going to be AP 515s, and I'll put them in the rooms where the users are. And because this actually is drywall between the rooms, not between the rooms and the corridor, but between the rooms. So actually that propagation's pretty good. So, oh, well, this is sort of, this is all right. There. No, one in there. Good. Right, we fixed it. But we can't do this because asbestos means we can't actually run the cabling in for these APs. So what is the answer? Well, to go back to here, oh, let's just skip past these. I don't need these because we've got a real live demo. We've got another poll.
Come on, our favorite poll. You asked the question. You need to take yourself off mute though if you're going to ask it. You're still on mute, Mac.
Soft mute, of course. So Paul asking, Paul, do you use hospitality wall jack APs in your designs? Answer A, all the time. B, very rarely. And C, what is this hospitality you speak of?
We'll give it a few more moments time to allow everyone to vote on the poll, not in the chat, please, guys, so we can see your answers. And I'll just give it a couple more seconds. I will end the poll, and then I shall now share these results. And if we take a look at the results, we can see that it's not necessarily super one-sided. I mean, about 25%
that's
of people,
interesting.
yeah, only a quarter of the people on, you know, you're looking at all the time. Very rarely was the highest at 46%. And then what is this hospitality you speak of at 30%? So this hospitality, will you be making people tea, Matt, or what are we talking about here?
Yeah, well, you know, I'm a Yorkshireman, so a cup of tea, absolutely. But yeah, yeah, I love these. I love these. Hang on a minute. Can we move there? Right. So this is the Aruba AP 505H. It's not this particular AP, but this format is one of my favorite formats, and hospitality is what Aruba call them. Wall jack is kind of a very common term for them, especially in the US. Cisco do them. I think Meraki have Cisco Meraki have it, and Mist now have a wall jack. I think they launched that relatively recently. It's the Aruba ones that I'm most familiar with, and we've been using them for a really long time because of asbestos, because they were a great solution to the problem of asbestos. And I'd never seen anything like this. It's like, oh, it's an AP and it screws over the network socket that you've already got and just plugs in, and then it's mounted on the wall instead of on the ceiling. Oh, that's kind of neat. And then once you've lived with that for a little bit, you go, oh my word, this has transformed my ability to actually install good Wi-Fi in a space. Because previously I was fighting with asbestos and I can't go in the ceiling and I can't do that. No. And oh yeah, if we want to do that, yes, we can do it. We'll have to clean asbestos. It'll cost about, you know, £150,000 and it'll take 6 weeks. And okay, so that's not happening for an AP, is it? And this allows us, me, whoever, to be able to say, right, we can use existing cabling and we can use existing data points, and it's relatively affordable and it's really easy. And yes, it's a compromise, but it's a lot better than what we had previously, which was, well, I can't show you now because I've moved all the APs, but you know, we saw it, the kind of grey despair all the way around the offices where nothing's going to work. So what actually you end up doing in a space like this is you use the wall jack APs, and we say let's use the AP 505H because, you know, it's the current model. I think there's a new one on its way, which has possibly got Wi-Fi 6E. maybe I'm not sure about that. Could be coming soon. So if we do something like this, we say, okay, so one AP with its sort of semi-directional antenna that they have, actually that'll serve, well, at least happily up to here. Let's just do that again. Well, okay, so we're good to there. And well, you know, we know this is an iterative process, and we go through and we say, yeah, this is what is going to work. And so the key thing about this and this approach is that you don't, still got some stalactite walls. So you can see quite quickly, you can have decent Wi-Fi in the space using the existing data cabling that's already there. You're not having to kind of drag in anything new, which is good because we can't. More importantly, it's really quick. So this approach started to become what I would do an awful lot of the time, not just in buildings that were full of asbestos, but also in spaces that actually were, it was just more convenient, basically. So let's come up with some examples. So these are just screenshots.
Just to jump in here, this is a really great example because actually you've answered quite a few of the questions in the Q&A now without even realizing, because we've had quite a few questions popping in saying how many of the what do you do in this situation? When do you use these wall jack APs? We had someone else say that they'd done a survey at a school recently that had lots of soundproof studios. So what should you do there? So by using this demonstration, I think that actually answers quite a lot of questions that we had coming in the Q&A. So by using these wall jack APs and placing them inside the room, you're providing that coverage in the room. You've been able to avoid all of this asbestos that you just mentioned, plus, you know, put in the coverage where your clients are inside of the room. So yeah, well done, Matt.
It's great when a plan comes together, isn't it? So this is just a screenshot of a much more modern building, but again, this is accommodation. What I should say is the building we were looking at previously wasn't actually an accommodation building. It was an office space, but actually there's not really any difference between them. What would happen with the older accommodation buildings that have asbestos in them is that you just got rooms off a corridor. It's exactly the same design because it's the same clasp building method. The only difference is that every so often you have a bathroom. So this is a much more modern accommodation building, and you can see that we've got a corridor up the middle of it, and it's got a funky angle here. But apart from that, corridor up the middle, rooms off either side. Nothing has really changed. This is a building that's 50 years newer than the previous building we were looking at, and it's kind of largely the same, although the materials are very different. We have these slightly challenging areas here, and what that's caused by is these, oh no, I didn't mean to do that, these washrooms. So what these washrooms are is a prefabricated little bathroom pod with you know, shower, toilet, sink and cupboard and stuff, and they're made out of like sort of concrete and steel as a rigid thing that gets factory built and then craned into the building when it's put up. A lot of hotels are built like this as well, and so it means if you rely on corridor APs, it's another reason why, you know, all the reasons they're a bad idea, but this is one. You've got these areas of really high attenuation that you don't necessarily realize are going to be doing that, and you know, this is what it looks like. But here is a building that, again, we've got a little desk in the corner of every study bedroom, and there's data to that desk. So we just use that, and we put the wall jack APs in all of those. I mean, they're called hospitality units, the Aruba models, and so this is kind of what they're built for. They're designed to put it by the desk. They've got data sockets on the bottom as well. They have the 505H has a 4-port switch in it, so you put that over your existing socket, and it gives you 4 ports. It's got PoE pass-through, so if you give it enough power, it can provide power. So it's a really flexible unit. And so, yeah, we use them here. This is inside Central Hall. So one of those earlier pictures I showed you of the kind of spaceship thing, this is what it's like inside. So this is during the setup for the Church of England's General Synod, which is a meeting that happens in there. Underneath this kind of balcony all the way around here are a load of data points, and nobody really knows why they're there. They seem to get installed by accident at some point. But we suddenly had a need to really increase the Wi-Fi capacity in this space, and it was primarily because we had a very, very early coverage design. Coverage in a big open space. Well, you know, that's really easy. And suddenly we've got conferences happening here. They all want to be online. You've got media people in there. They all want to be online. And so you have that combination, high density kind of combination of both a lot of high numbers and throughput required. And the way we did it in here was we just put those hospitality units, fasten them onto the ceiling underneath this balcony all the way around. And I can't remember how many we used, but it was quite a few, because they've got like a semi-directional antenna. So you can end up with a really contained cell size to an area of seating, and it worked fantastically well. So they were a great solution for there. And if you look at their spec sheet, you'll go, oh, well, this is no good for high density because it can only handle however many users. But of course, a high density design where you need to have quite a few people and quite a lot of bandwidth, you don't want to put a lot of users on each AP. You want multiple APs, lots of cells, and you want to spread the load. It worked a treat. It wouldn't work in all circumstances, but it did in this one, mainly because we had fairly short distances to work with. This is a photo I love, and I wanted to include it because it's about the importance of validation more than anything else. And to say that when we looked at the building, the class building, and we said, oh, well, it's drywall between all the offices, so therefore, yeah, easy. No, yeah, absolutely, it is drywall. That wall that you can't see because it's behind books is drywall. But then it's got like an extra, what, foot, maybe even, yeah, a good foot extra depth on it just in books. There isn't really a space in this room that could have a book on it that doesn't. And also, because our data points tend to be mounted quite low on the wall, we're trying to push the signal through this solid wall of paper, and that's, you know, that's never great. So yeah, it's important to actually look at the reality and see what's out there. Really quickly, because we're running out of time, I cannot talk about higher ed without mentioning Eduroam. I'm going to assume that no, I'm not going to assume everybody knows what Eduroam is. So really quickly, what Eduroam is basically the ability for you to authenticate via Radius with another organization from the one where you are. So Mac, for example, you are at the University of Loughborough and you have decided that you're going to be doing a bit of work in Reykjavik. So you're now at the University of Iceland, you rock up, you get out your high-end MacBook and you open it and it connects to Eduroam and it just works. And the way that works is you talk to the University of Iceland Radius server and it says, I don't know who you are. I'm going to ask someone else. And a little bit like DNS, it just passes it up the chain till you get to a top level Radius server that goes, I know what to do. I'll go and talk to University of Loughborough, and you get online. Eduroam is a victim of its own success, and it causes some big headaches for people because it doesn't support PSK. It's .1x only, of course, and we have all sorts of ongoing questions about should we turn off 2.4 gig on Eduroam. If you saw Peter Mackenzie's talk at the Wi-Fi Day, he raised this. And if you haven't seen Peter Mackenzie's talk at Wi-Fi Day, I urge you to watch it because it's Peter Mackenzie, so it's excellent. But he raises some really interesting questions around Eduroam and around the future of Eduroam and how we deal with it. Someone specifically asked me a question about this and said, we need to get rid of .1x for this environment. And I have to say, I sort of agree. I think .1x and Eduroam is brilliant. I love Eduroam and I love what it enables. I love that flexibility, the fact that anyone can go anywhere and it just works. But the problem is all those devices that don't support it. And then, well, Eduroam's a really good idea. So why don't we start another one and call it GovRoam? And then we could have another one and we could call it OpenRoam. And then we could have another Roam. And before you know it, your SSIDs are proliferating. And I think to answer the question that was raised, and I'm really sorry, I can't remember who asked it of me on Twitter. I think
I'm pretty sure it's
Passpoint.
Paul.
Oh, it was Paul. Yes,
Yeah,
you're right. It was.
Yeah.
Thank you, Paul. I think Passpoint, Hotspot 2.0 is the answer. We've got the technical answer to this to deal with how to make, the idea is how do users connect to Wi-Fi easily, seamlessly. You make the onboarding relatively straightforward and then it just works wherever they go. And you don't have to offer a billion SSIDs. Passpoint is the answer to that, but it's so hard to achieve because of client support and because of just getting the ball rolling on it. It's hard. The guys behind Eduroam are pushing for it, but it's hard. And the way Eduroam is done at the moment,
is it, Matt? Also,
sorry?
Open roaming also is becoming quite popular, and it's also
absolutely
based on
yeah.
So
And
this
it's
is the future.
It absolutely is the future. And Eduroam has been doing this for years, and it's kind of been leading the way on it. And there's a slight risk that it kind of gets a bit kind of left behind, because you know what it's like. You're doing a thing, it works. It's much easier to leave it alone, isn't it? But yeah, I think I like Eduroam, and I don't think it should go away. I think it should embrace Passpoint. That is what I think should happen in order to make it kind of fit for the next stage. And as for the question here, I'm with Peter Mackenzie, and I think that Eduroam should be 5 gigs only. That's my thought on that. And so I think at that point we have to skip forward because we're kind of out of time.
It's been so good though. It's such great information, and I think this is we've got. I just looked at the best part of 45 questions in the Q&A. Everyone's loving it.
Man. Wow.
So yeah, let's
right, I'm gonna have to go through these, and I'll have to bring us to this.
We gotta stop here, because what's this? We have a swag giveaway. I'm getting a little bit warm in my apartment here. Actually, I've got look at this. There's some Ekahau playing cards, and all you gotta do is scan the QR code using your mobile device. And what it's going to do, if you look at Anita Reuter, her tweet, it's going to tweet that tweet for you. And we have got 20 of the Ekahau playing cards to give away. These can be great stocking fillers, or you can keep them for yourself, or if you get a little bit worn, you can be using it. I'm getting a bit flushed here. Could be get maybe a bit of a royal flush. No, bad jokes. Sorry, people in the Ekahau marketing team are kind of known for my bad jokes now, so apologies for that. But I'm actually going to get involved. I want to tweet this. I want to get some more cards. So I'm going to scan the QR code. There we go. Go to Twitter. Let's open up my Twitter, and I am posting it. So there we go. Now I'm in the running to get some free swag Ekahau cards. Thank you very much. What have we got on the next slide, please, Matt? Because we have something else, which is a fantastic resource that the marketing team have put tons and tons of effort in. And if you've not seen it yet, it's a free guide. It's our 3 easy steps to great Wi-Fi every day. There's 34 pages of amazing Wi-Fi goodness that's now available in this. So again, all you've got to do is scan the QR code, and what that's going to do is going to take you to a website where you can download this for free. And I could not highly recommend this enough. There's so much amazing, great content in there, and it's for free to help you to make sure you can design great Wi-Fi. So everyone, please go and scan that QR code, go and download it. If you've not downloaded it, tell your friend to tell a friend, because the more people that know about the 3 steps to great Wi-Fi every day, the better Wi-Fi is going to be for us as users going to be able to connect to that Wi-Fi. And then the next slide, please, Matt. I think that's it really. So yeah, apologies, we ran over slightly today, but since it was the last one of the year, we know you'll sneak that extra little bit of content into there. So what I'm going to do now is I will end the recording, and then we'll take maybe a few of these questions offline for Matt. I see there's so many in there, so we can, if Matt doesn't mind hanging around for a few more minutes, we will we'll ask him some more questions. But thank you everyone that's only staying on for this part. We wish you all a fantastic holiday season over the next time. Take some good downtime, have a nice break, and we'll see you back in the new year. So thank you everyone for joining us with the webinars this year, and thank you Matt so much for this amazing presentation today.
It's been an absolute pleasure. Thanks for having me.